Okay, solving systems of equations here using conic sections. So here we got an ellipse, x squared over 36 plus y squared over 9 equals 1. It would look something like this. Y equals x squared minus 4. That's a parabola, right? With a vertex at 0, negative 4. So it's going to look something like that. And we should be able to find all 4 points of intersection, right? Okay. Alright, we don't really graph these on our graphing calculators to help us find those points of intersection. This one would be easy to graph. If you wanted to graph the other one, you'd have to get y by itself and you'd have to type in 2 separate equations for it. Because when you get y by itself, you'd get a positive square root of something and a negative square root of something. So you'd have to enter both of those equations. One would give you the top half of the ellipse, one would give you the bottom half of the ellipse in a sense. Okay? But we're going to solve it algebraically using substitution. So, I might, if I were doing this, I can either take this and substitute in for y, then I have to square it. And squaring that would give me x to the fourths. You guys see that? I kind of want to avoid that. So instead what I'm going to do is I'm going to solve for x squared and then just substitute it directly in there. You guys see what I'm doing there? So x squared would equal y plus 4, right? So now I'm going to take y plus 4 and just put it right there in place of the x squared. Okay? So I have y plus 4 over 36 plus y squared over 9 equals 1. Everybody okay so far? Okay? How do you want to solve that? Put them all over the same denominator, or how about we even get rid of the denominator? What you said is perfect. Okay? But how about we get rid of denominators? That'd be even better? How could you get rid of the denominators? Multiply everything by least common denominator, which you would have done by creating everything to have the exact same denominator. Because what Bailey was thinking, okay, you were thinking take this times 4 over 4 to give it a denominator of 36. And then take this times 36 over 36 to give it a denominator of 36. And then since they all have a denominator of 36, you can really just ignore the denominators and write out the numerator part. Okay? Or just multiply everything by 36 to begin with. Okay? If you take both sides of the equation by 36, well, what's 36 times this fraction?
Y plus 4.
Yeah, y plus 4, because the 36 is canceled, right? 36 over 1. 36 over 1 times this over 36, the 36's would cancel and you'd have y plus 4 over 1. Okay? How about the next fraction being multiplied by 36?
3y squared.
Careful.
4y.
4y squared. Okay? And then that equals 36, right? Okay?
Where did that 4 come from?
Sure. So when I take 36 over 1 times y squared over 9. So 36 over 1 times y squared over 9. Because I got to take the 36 times both of those things, right? Okay. And when I took this times that fraction, you're okay with the y plus 4? Okay, so when I take 36 over 1 times y squared over 9, 9 goes into 36 how many times? 4, so that becomes a 4 over a 1, so now I have 4 times y squared over 1 times 1, 4y squared. Is that okay?
Yeah.
Okay, good. Now I have a quadratic equation. How do I solve quadratics?
You get one side equal
Set them equal to 0 and hope we can factor it and avoid the quadratic equation. I don't know, we made this problem up.
4y squared.
4y squared plus y minus 32 equals 0. don't think it's going to be factorable. So, quadratic equation. X, or y equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. That's a negative 512 in here, so 1 minus a negative 512 would be 513. So negative 1 plus or minus the square root of 513 all over 8.
Would it be 511?
What did I say this was?
500.
Negative 12.
Negative 512, so 1
Oh.
minus negative 512, so plus a positive 512.
Yeah, okay.
Yep. So negative 1 plus the square root of 513 divided by 8, 2.706. Negative 1 minus the square root 513. All of that divided by 8, negative 2.956.
So are you using a rounded y value to find the x?
I am going to, yeah.
Can we do it on a test or not?
Okay, yeah, that's fine. I think the ones on the test are going to be factorable,
Oh, okay.
so I don't think you're even going to have to mess with this. All right. Yeah. I mean, I know for time purposes I'm going to make them factorable for you. All right, because factoring so much faster than this. So those are your y values, okay? Now, if these are the y values, we got to plug those in to get the x values, right? Okay? So, if I come over here, so let me take 2.706 plus 4 equals x squared. So in other words, 6.706 equals x squared. Then when I square root that, the calculator is only going to give me one answer, but we know it's plus or minus, right? Okay? So x equals plus or minus, and then let's just round that. 2.589. Plus or minus 2.589. Okay? So that tells me then that two of my solutions are 2.589, comma 2.706, and negative 2.589, comma 2.706. Because I know that the x value could be positive or negative if that was my y value.
You have to do it again.
Then I have to do this again with my other y value, right?
Yeah.
So, negative 2.956 plus 4 equals x squared.
1.044.
Thank you. 1.044 equals x squared.
And then 1.0217.
1.022 plus or minus 1.022, and you square root that. So then my other answers would be 1.022, comma, negative 2.956, and negative 1.022, comma, negative 2.956. And that seems to make some sense. These 2 points of intersection would have been located there and there. And these 2 points of intersection would have been located there and there. Okay. Ones on the test are going to come out nice, you're going to be able to factor them. Okay? But the process is the same. So you're just finding points of intersection. Any questions on that? Alright. For practice, we'll do those problems right over there, right underneath where it says graph. Y equals x squared minus 4, y equals negative x squared plus 6, and so on all the way down. So there's really just 5 parabolas I want you to graph. If you're able to graph each one of those different types of parabolas there, you'll be fine for graphing parabolas on the test. They're almost identical to this, just the numbers are different. Okay? And then here's just 3 problems using solving systems of equations. Okay, so overall it's only 8 problems, not very many. I think it'll be enough to get you to where you're fairly strong at the skills we needed to be for today. So graph parabolas, solve systems, and the only other thing for today is know the definition of a parabola. Okay? And for those of you that were gone, definition of a parabola, you'll see a picture of the parabola up there. The parabola's in blue. You'll see a focus inside the parabola. There's a line below the parabola called the directrix, and you'll notice the definition. Just kind of memorize the definition. Parabola is the set of all points in a plane such that its distance to the focus is the same as it is to the directrix.